We are talking about linear word problems, and we want to be able to identify rate of change in word problems, be able to identify the y-intercept in word problems, and write linear equations in slope-intercept form. So here we have question 3, and it says, a machine can make 5 miles of ribbon in an hour. Graph the length of the ribbon of the machine will make in 8 hours. Another machine can make 8 miles of ribbon in 1 hour. Graph the length of the ribbon the machine will make in 8 hours. What is the difference in length for an 8-hour period between the two machines? Write an equation in slope-intercept form for each machine. So again, we want to start by finding the slope, and we want to be able to identify the 2 units for each. So we have 2 different machines, and another machine. So graph the length of the ribbon the machine will make. So a machine can make 5 miles of ribbon in an hour. So we have 2 units, miles of ribbon in an hour. So that's going to be, we'll call that the slope of machine 1, and that's going to be equal to 5 miles of ribbon in 1 hour. The next one that we have, another machine can make 8 miles of ribbon in an hour. So there we have the 2 units again, miles of ribbon in an hour. So we'll call this M2. So it says, graph the length of the ribbon the machine will make in 8 hours, and then find the difference. So we have the slopes, and we have all the information that we gave, except for we want to find out how long it will be in 8 hours. So the next piece of information we need to identify is we need to identify the starting point for each. So in this case, when we look at our B value for each one of these, the B value is going to be, we're starting at 0 miles. So we're starting at 0 miles for each of those because we want to see if they both start at the same time, how much difference will there be after 8 hours? So we have the coordinate pair 0, 0, and 0, 0. So this is going to be our y-intercept. So both graphs will start here. Now, the other thing we need to identify is our x-axis and our y-axis. And one thing that really helps us out is time is usually always the x-axis, but the other thing that helps us out always is we have the y units in the numerator of the slope, and we have the x units in the denominator. So the x units in this case are going to be hours, and the y units are going to be miles of ribbon. So now we have our equation. If we have y equals mx plus b, and then we have y equals mx plus b, we can substitute the values in that we know. So for our slope, for M1 here, we have a slope of 5. When we're writing the equation, the x and the y are always variables. We leave those as variables. And then we can add our b value, which is 0. And we have the same thing here. Our slope is 8. X and y remain in the equation, and our y-intercept ends up being 0. So in this case, we can just drop the 0 off because adding 0 doesn't change it. And just for graphing purposes, I'm going to change this equation to be y equals 5x, just to make sure that it stands out a little bit more. And this one we can say y equals 8x. So we want to see what the difference is after 8 hours. So we're going to substitute 8 hours into each equation, and then we're going to see what we get. So y equals 5 times 8. So in this case, we get y equals 40. And when we substitute 8 into this equation, we get y equals 64. So we have the ordered pair of 8, 64. And then over here we have the ordered pair of 8, 40. And for both of these equations, the starting point is going to be 0, 0. So when we go to graph this, we have to make sure that we can make it, the graph that we have will account for all of our coordinate pairs. So on the x-axis, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we need to get up to 64. So probably a good thing to count by would be tens. No, that's the y. So we want to get up to 8. So a good thing to count by would be 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And a good one to count for, now the y value has to get up to 100, so a good one to count would be tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we can graph, both of these points are going to start out at the origin, which is 0, 0. We already have that plotted. And then we need to do the 8, 40. So if I go over 8, and then we go up 40, 10, 20, 30, 40, right there. And then we can draw the line that goes between those. And if this machine continued to work, it would continue to produce miles of ribbon. And so we can draw that and have it go through there. And then if we go 64, so that's 4, 10, 20, 30, 40, 60, 64. And then we can draw that line that connects the origin to 864. So what we want to find out is, what is this difference right here, or how far are those apart? And one way we can do that is we can just subtract these two. So we can say 64 minus 40. So that's going to be equal to 24. So the difference in length is 24 miles per 8 hours.